Today we're going to look at quadratic systems. In algebra, you learned how to solve linear systems, and this year we're going to learn how to solve quadratic and linear and quadratic systems. So remember that systems can be solved by graphing, and wherever the lines intersect will be your solution. They can be solved by substitution and by elimination, and we're going to look at all three of those in this lesson. So we're going to solve this system by graphing. I have a parabola and a line. So if I graph the line first, my y-intercept is 1. My slope is 2, so I'm going to go up 2 and over 1, up 2 and over 1, or down to negative 1, negative 2, negative 1. And I'm going to graph that line. Okay, my parabola, we're going to use negative b over 2a to find the x value. So negative 2 over 2 times negative 1 give me negative 2 over negative 2, which is 1. And then I'm going to plug it into the equation. So negative 1 squared plus 2 times 1 plus 1. So that's going to give me negative 1. Remember, we're not squaring the negative. We only square the 1. Plus 2 plus 1. And if I simplify that, my y value is 2. So my vertex is 1 and 2. So my vertex is 1, 2. It's going to open down. I'm going to go over 1 and down 1 on both sides, over 2 and down 4. And you can see we've already found our intersection. It's not a very good graph. Let me do that again. And so it just kisses and intersects at that 1.01. Now, if we had a line that cut through the parabola like that, you could have two solutions. If it didn't cut through the parabola at all, there would be no solutions. Okay. Now let's solve this system by substitution. Since they're already solved for y, I can set them equal to each other. So x plus 1, we're substituting in for y in the top equation, equals x squared plus 4x plus 1. It's a quadratic, so I have to bring everything over to one side. So I'm going to subtract 1 and get x equals x squared plus 4x. I'm going to subtract x. So I get 0 equals x squared plus 3x. I can factor this by factoring out an x. So I get x times x plus 3. Set both of my factors equal to 0. So x equals 0 and x equals negative 3. Okay. Now I'm going to plug my x values back into the easiest equation. It can be either one, but I'm going to pick the easiest one, the y equals x plus 1. So y equals 0 plus 1, which is 1. So my ordered pair there is 0, 1. It's important that we keep them together. If I put in negative 3, y equals negative 3 plus 1, or negative 2. So that ordered pair is negative 3, negative 2. So I have these two solutions. Okay. Now, elimination, we can add or subtract the equations to get the solution and eliminate a variable. So if I'm looking at this, and a lot of times elimination isn't the best thing to do with quadratics, but I do have a y and a y right here. So it's the only y's I have, so if I subtract these equations, I can get rid of the y's. So x squared minus a negative 2x squared is 3x squared. Negative 17x minus 34 is 51, so minus 51x, and then 65 minus 145 is 210. Now what you should notice to make this easier on you is that all of my numbers are divisible by 3. So I'm going to divide everything by 3. So I'm going to get x squared minus 17x plus 70 equals 10. You can then solve this however you want. You can use a quadratic formula, you can complete the square, you can factor. But I'm looking at 70, and my factors of 70 that add to negative 17 just jump out at me. It's negative 7 and negative 10. So I'm going to factor it so that I get x squared minus 7x minus 10x plus 70 equals 0. And then I'm going to pull out an x, so I get x minus 7. Pull out a negative 10, I get x minus 7 again. So my factors are x minus 10, x minus 7 equals 0. If I set those equal to 0, x is going to be equal to 10, and x is going to be equal to 7. Now I want to pick the easiest equation to put it in, and I'm going with the first one because the x squared, they're not multiplying. So 10 squared minus 17 times 10 plus y plus 65 equals 0. And if I simplify that, I'm going to get 100 minus 170 plus 65 plus y equals 0. And that is negative 5. So I get negative 5 plus y equals 0. So y equals 5. So one of my solutions is going to be 10 and 5. Okay. And then for 7, I'm going to put 7 in. So 7 squared minus 17 times 7 plus y plus 65 equals 0. So 49 minus 119 plus y plus 65 equals 0. When I combine my like terms, I get negative 5 again. So y equals 5, and my other ordered pair is 7 and 5. All right, last example, solve this system anyway. Again, you could solve one of them for x if you wanted to and solve by substitution. Or again, if you notice, I have the x's here. So I'm thinking that I probably want to get rid of the x's by subtracting. So if I subtract this, y squared minus y squared is 0. X minus x is 0. So those cancel out. And negative 10 minus negative 19 is 9. 16 minus 70 is negative 54 equals 0. So 9y equals positive 54 and y equals 6. And then it really doesn't matter what equation I put it back into. They're pretty much similar. So I get 6 squared if I put it in the first one, plus x minus 10 times 6 plus 16 equals 0. So 36 plus x minus 60 plus 16 equals 0. If I combine my like terms, I'm going to get x minus 8 equals 0. So x equals 8, and my solution is 8 and 6. Okay. So we looked at a couple examples today of how to solve a linear system with a linear and a quadratic and a quadratic and a quadratic. We solved them by graphing, by substitution, and elimination. If it doesn't say how to do it, pick whichever one you find is the easiest. Can I eliminate a variable? Is sum already solved for y? You make that choice. Have a math-tastic day and like and subscribe.
Yay.